Sorry about that. Sometimes it's easier if I split up the videos and then it doesn't take as long to load. So last step here is to format your answer. So 11.3. All right, next page. So here's a good time for you to pause the video and go try the you try 1 and then you try 2 on your own, and then come back here for the worked out solution. So pause the video, go try it, and then come back. In this particular case, I noticed that the 2x and the negative 2x will cancel each other completely, so that works out really good. We've got 2y equals 4 when I add straight down. Y equals 2. And then take that and plug it back in. I'm going to choose the top one since it's all positives. So 2x equals 1. X is 1/2. Don't be scared of that. That's okay. So format my point, 1/2, comma, 2. Remember, this was my x value, so it needs to go first in my point. And then the u try 2. What I notice here is that the y's are opposite of each other. So this is a plus y and a minus y. Those are the ones that are going to eliminate. If I add straight down, I have 2x. If I add straight down, I have 36. So x is 18. And then pick one to plug that back into. Again, doesn't matter. I'm just picking the top one for convenience. And then subtract 18, and I get 12. So y is 12. And then format my point, 18 comma 12. All right. So the next set of examples is what happens, or what do we do if we don't have opposites already built into the problem? So if you look at the x values, we have a 6 and a negative 4. They're not opposites of each other. They won't eliminate. And if you look at negative 7y and negative 7y, they're not opposites. They're not going to eliminate. So what do I do next then? Well, there's this thing where we can multiply by a specific value in order to create opposites. So I'm looking specifically at this y column here, and I'm saying to myself, you know, negative 7y and negative 7y, that's really close to being opposites if only one of them were positive. And then it wouldn't be so bad. So all I have to do is somehow create a negative into a positive. Well, I can do that by multiplying by a negative. And it doesn't really matter which one I create negatively and turn it into a positive by multiplying by that negative. So I'm going to look around it and say, well, would it be better if I were able to turn this into a positive and a negative? Or maybe in the first equation a negative and a positive? It doesn't seem to really make a difference. So I'm going to go with the bottom one simply because it'll help me turn this leading coefficient into a positive. So I am strategically choosing to multiply this entire equation by negative 1. And so what I want you to do every time that you do one of these problems where you have to multiply is rewrite the entire problem after you've done it. It'll help you not lose signs, and it'll help you stay more organized. So if I multiply every single thing in this equation by a negative, this becomes positive 4x, this becomes positive 7y, and this becomes negative 26. And now I've purposefully created opposites in my problem. And my y's will cancel on purpose. So this is 10x if I add straight down, and this is negative 30 if I add straight down. So x is negative 3. Now here's the next tricky part with having to multiply by a value is sometimes kids will take what they just solved for, so in this case our negative 3, and they'll plug it back into the second equation, which is the one that we changed. You don't want to do that. You always want to go back to the originals in case you mess this up. So I'm going to go back up to this problem that says 6x minus 7y equals negative 4 and choose that one because I didn't do anything to change that problem, or that equation I should say. So I'm going to use 6 times negative 3 minus 7y equals negative 4. This is negative 18. I'm going to add 18 to both sides, and that makes this 14 over here. So y is negative 2. And of course, format your point when you're done. Always, always, always format your point, right? Okay. So let's do the redo. So pause the video here and see if you could decide if you recognize what it is that you have to multiply by. And hopefully you said one of these equations, I can make opposites out of these x's by just making one of them negative. So I'm going to choose negative 1 on the bottom again. That's just coincidence. You could choose any number you need to. I could have multiplied the top by the negative, and it still would have created opposites. I'm choosing the bottom equation because I realize that that negative will help these other two values turn positive, and then I don't have to deal with negatives in my problem. So remember, always rewrite your entire system. So that's the top equation. I didn't do anything to it. And now I am changing all of these into what it would look like if I distributed that negative 1. And now I've got a problem here. Now I've got this problem here that I created opposites with. So my x values eliminate. I have 5y equals 15, y equals 3. And then remember, go back to your original equation. I'm going to choose the top one just because it's got all positives in it and that makes it easy to work with. So x plus 3 times 3 equals 9. So x plus 9 equals 9, x is 0. And then format your point when you're done here. 0, 3.